Hello, everyone. My name is Mohit. I head the engineering team at Komprise. And I want to quickly jump in the demo, and I'm going to have just one slide before the demo that really talks about high-level architecture of Komprise so that you are aware of some of the terms that I will be using throughout the rest of the demo. So, some key components here, right? I think the one that you see on the top is Komprise Director, which is our administration console, kind of runs as a service for most of our customers, hosted in Komprise Cloud. And for some high security conscious customers, this can be deployed in their data center as well if required. Right? So this is one of the very key pieces that you'll see in most of the demo. This is where you drive and use the product. But the actual work and a lot of what we do and insights that we gather and the data movement happens from these site-specific Komprise grid. It's a scale-out architecture. These are all software-based solution, virtual appliances that customers download, deploy in their environment, and they go connect to the Komprise Director, and here we can manage the data that's sitting on the file stores or object stores or data in their data center by sitting close to the storage itself, right? And till now, we used to have this pods of director and observers of different sites. But recently we have announced in 4.0 where you can manage your multiple data centers with your individual site-specific grids with this unified console director, right? So you don't have to go to different URLs. It's a single site, single point of URL for you. So unified console where you can go and manage all your data centers across different sites easily. And here down you see is, this is your choice of targets, right? Kumar talked about where you can, Komprise comes ahead and analyzes the data, finds that cold data, and you can move the data to your choice of object storage, your choice of cloud, and Komprise is not kind of involved there. You pick the cloud you want to choose, whether it's AWS, Azure, or an on-prem object store, and Komprise does not store any of the data. All the data goes directly to customers' storage accounts as well. So there'll be three parts of the demo that I'll talk about, right? And I think it all starts from know first, right? So you want to be able to quickly assess.
Hey Mohit, a couple of questions. So is the data encrypted when it goes out to the cloud? Is it deduped and or compressed? That sort of thing. I mean, what is it? Is a file effectively an object, or is it split across objects? Those sorts of questions.
Oh, excellent question. And I think I'm going to show that in the demo as well. But let me answer quickly. Everything is encrypted, right? Now, we support multiple level of encryption by default. It's definitely encrypted in transfer over HTTPS. There's nothing goes without HTTPS, and it's encrypted at rest using most of these cloud stores have the server-side encryption. Whether it's server-side encryption default, or you can use server-side encryption using their key management service, right? So it's their encryption, or there is an end-to-end encryption solution as well. And I'll talk a little bit more about in the demo as I show that, hey, how it looks in the cloud. But by default, I think one of the key differentiator that we have with TMT and how we move data is these objects are accessible directly going to S3. That means they're native. We are not mangling anything. We are not like chunking one big file into multiple objects. We are not, creating one object from multiple files. Because what we want to enable, and I think, have customers have control of their data, they can directly go to this object store, and I'll show you that in the demo as well, and really use a lot of AWS or Azure or Google Cloud services, point to this data, and really leverage the power of the data rather than it's only accessible through some proprietary format.
So it's not deduped, it's not compressed, it's a flat file per object kind of thing.
It is not deduped. We have an option to compress. If you do choose to compress, then obviously, right, it's only accessible through Komprise, because then we would have to decompress the data. Yeah.
All right. Thank you.
Great. So yeah, so the first section will be the analysis, the visibility, and then how do you take action on the data across all your data centers. We'll talk quickly about deep analytics, and I'll then jump into, hey, what's the end user experience of TMT looks like, because that's going to be a really good transition to what Mike will be talking about about our architecture of TMT and how that's really a magic behind what Komprise does. So let me just quickly go and jump right to the demo so we don't spend too much time talking on the slides. Okay, I think, yeah, it's a little bit big, but I'm sure everyone can see the screen here. So what you're looking at here is a Komprise director here. This is the administration console, and I know it's kind of scaled out at least for me on the screen. But this is where the administrators come to manage their data across all their data centers, right? So in this case, what you're looking here is in this site, customers have added their file servers and they pointed Komprise to their NetApp and Isilon. It could be anything they have in their environment, NFS or SMB file shares that we can work with, or even mixed protocols. And in this case, there are a bunch of file servers. They have about petabyte of data sitting in Boston. And once they really add that to Komprise, Komprise is able to, within minutes, give you a quick snapshot, a quick analysis of your data. And what that includes is this really cool heat map where you can exactly see how much data do I have sitting in this data center, how much of that data I haven't accessed for over 2 years, over 1 year, over 6 months, and not only the heat map of the data, but we give you a little bit more information about it, where you can see what kind of files do I have. Hey, in this case, I have a bunch of video files sitting, about 140 terabytes of data sitting in my environment, and then there are a bunch of archive and log files. And not only what kind of files you have, but even within the type of files, how many you haven't touched for a long period of time. How many of the files are big or small, or how much of the data is being taken in your environment. How much of the data is owned by users who may have left the organization, or by the engineering group versus the marketing group, right? And this insight, it's very surprising, right? You go to the customer's environment, within minutes they see, wow, we never had that insights before. And coming back to kind of what Kumar pointed out as well, where in the case of Pfizer, where they were able to quickly see, once they kind of deployed the product and they're across the data center, about 65% of their data hasn't been touched for more than 2 years, right? And in this case, it's kind of a similar number as well. Now, once you have that insight, what you can also do right within the tool is you can create your policies, right? And you can do what-if scenarios where, hey, I want to see if I move all my data that's sitting in the environment, let's say if it's older than 1 year, I want to move it to AWS. What will really happen? Once you do that, I don't know if you noticed, this shaded purple in the heat map changed, because that really tells you, based upon the policy that you have configured, you would really move 50% of your data to AWS. Not only it tells you how much data will be moved to AWS, but it also gives you, hey, based upon the data you have in your environment, your data growth and cost of your storage, how much savings are you going to be getting once you take that action, right? So in this case, it's a $3 million of saving, and that's really was the key to even Pfizer as well, right? Where they could get this report, they could really make the decisions about the data based upon the assessment that they were able to do using Komprise. And not only the cost saving, if you go a little bit down here, you can see exactly, hey, this orange line is, what if I don't make any changes, right? I don't use Komprise, or I don't move this data to AWS, what would happen? It really tells you, based upon the data growth that we have captured during the analysis, your footprint will go from 940 terabytes to roughly 1.6 petabytes. So there's about 70% growth that you will see in over the next 3 years. You will need to buy additional storage. But if you do take action, you do use Komprise to move data, you would only be, you'll be reducing your footprint really in the next 3 years. So you don't need any additional storage, and you can leverage your current storage, but really move and start, moving that data to the cloud in a much smarter way. And when you're ready to make the decision, you have really understood your cost savings and everything, all you do is just come here, activate the plan, and Komprise will run this plan continuously in the background, where it will keep move this existing set of the cold files. But as more files get aged out, it will automatically keep moving the data in the cloud. In the cloud.
I have a couple of questions.
Sure.
One is, so can I choose also when I have my target object store in the cloud, a specific tier for type, depending on the type of file, or maybe on how old is the file? So maybe moving 3 years old file in a very cold tier, and moving 3 months old files in a, I don't know, warm tier.
A great question, Rico. Absolutely, right? I'll give you an example of AWS. I'm sure other, Azure and Google also have different tiers, and we do support them. So absolutely, right? We have a lot of customers doing that. Where they say, hey, I want to move my, data right away to S3IA because, hey, that's the cheapest one. It's infrequent access. But after it's being, it's more than 2 years old, I know it's never going to get accessed. It can go to Glacier or Deep Glacier as well, and Komprise will automatically do that. Same thing for Azure. We support the Azure Blob Hot Cool and the archive tiers. Google also nearline storage and the other tiers that they have as well. We support them, and you can configure your environment in a way that as the data gets colder, it gets further pushed to the more, in Kumar's presentation, more offline storage, because you don't need that access right away to the data. You still are able to find that data using Komprise and our TMT technology. You can see the metadata on your storage, but it's really sitting in this, in the deep archive. And when you need it, you can easily get the data back and access it as well. Great. So I think what I really quickly covered here is I showed you how you can use the Komprise analysis to understand what you have, know first. And really then using Komprise, in this scenario, we talked about how you can move the cold data to cloud, right? But as Kumar mentioned, we not only just archive the cold data, right? You may have some other use cases about your data once you have understood what you have, which could be, hey, I want to really make a copy of my data to protect from ransomware to cloud, right? So we also support that. So here you can see, you can come here and you can configure your plan that, hey, I want to make a copy of my data that's sitting to AWS S3, right? And we will do that. We will, again, it's a continuous running plan where any changes that happens to your data sitting on your storage, Komprise will go ahead and automatically make a copy of your data for DR purposes, from ransomware protection to AWS, AWS, Azure, any cloud storage of your choice. The other use cases, that we, I know there was a great question about deleting, right? So you may want to, identify, I want to see all my data from a compliance perspective, from GDPR or other compliance reasons. I want to find data that's colder than 7 years old, and I want to just really kind of delete it. I don't want to store any of that data anymore. So you can really use Komprise Analytics to find it and really select the confine, and we will just move those files to another location. And you go ahead and kind of wipe that off completely based upon customers' preference. And a lot of customers are doing that as well, but they're really confining it to another location because they have compliance reasons that they don't want to store any files older than 2 or 3 years old in their environment and not being accessed at all. The other big piece that we always use, another big data management operation that we always see, is customers are constantly modernizing their data center. They're moving to, again, going back from the different tiers of storage that Kumar had, we have the flash hot tier, right? Where you want to be able to have your hot data sitting in the flash storage. So they're moving from their current old NAS to the new modern NAS, which is kind of flash storage. And how do you do that really in a fast and an efficient way? So Komprise also have a way to migrate your data as well, right? So here in this case, I have my migration running, where I'm moving from one NAS storage to another NAS storage, and Komprise, using the same data management engine that you saw that was archiving the data, can very efficiently, in a very scale-out way, very fast, and give you the insights about as it's migrating, can make the migration painless for the administrator. Right? So all that is kind of included right in your one one tool, one management console where you can assess your data and you can take any of these data management operation using Komprise.
So Mohit, you mentioned earlier, I think the Komprise grid cluster, which are the devices sitting in the data center. If you're moving petabytes of data from one system to another, these guys are going to be fairly busy doing that. Do you scale? How do you? You've mentioned scale out, so there must be some sort of servers that you can add more and more servers to if you wish, up to some cluster max. But I guess how do you size those servers?
I think great question. So I think the biggest thing there is, first of all, our architecture, and I think both Kumar, Mike, and Krishna, they all have great experience with distributed systems, right? Two of them are PhDs in distributed systems, and they have designed many systems considering all of that, right? So the way we scale it is there are multiple level of scaling. The best way is to scale out our observers, right? Where these are, again, they're all virtual appliances. You can add and remove any time. So if suddenly you have a need of, moving that petabyte of data initially, and a lot of customers do that, right? Initially, they have a bunch of data they have to move, so they need more power, more compute resources to be able to do that. So they add more observers in their environment, and Komprise automatically distributes the load across these observers as it does the data transfer. And once that data transfer has happened and it's a steady state environment, they can reduce it. They can just remove those virtual machines, remove them from the grid, and Komprise auto adjust and then can able to handle based upon the resources available. We do provide some sizing recommendations to customer. It's generally kind of based upon amount of data and number of files and really some of the other aspects in performance that always comes in. Hey, what's your network throughput? What's your source? What's your target? Right? So kind of assess that to be able to understand your environment and then add and remove observers accordingly.
But they're always virtual appliances. You mentioned observers. It's the same thing, whether it's an observer or moving data mover or something like that. It's all the same.
It's all the same. It's a very architecture that the same system analyzes it, same systems moves it. As well, and they're all, you can just keep adding more if you need, all software-based solution.
All right, thank you.
Hi, Mohit. Jason, I have a couple of questions just following on from what Ray had asked there. So how far have you tested the scale? I work on exceptionally large data sets into the billions and billions of files, so I'm kind of just interested in where you are on that. And secondly, are you able to preserve all of the attributes, A time, M time, C time, soft links, symbolic links, hard links, those sorts of things? Because there's a lot of data there, and how do you handle that?
A great question, Jason. And I think let me answer the scale aspect first. Majority of our customers are multi petabytes and billions of files, and I think our largest customers are all around 85 to 100 petabytes of data. Right, and so we absolutely, I think most of our customers are at that level as well, right? I think most of them, they definitely go above 10 petabytes. It used to be 1 or 2 or 3 petabytes like 3-4 years ago, but we are now seeing at least 10 petabytes coming in for most of the customers, right? So definitely, we have handled that scale, and we have been doing that for a while now as well. I think the second question, very important, right? The fidelity about the data, right? You don't want to lose anything, right? And I think that's one thing is key for us as well. As we are moving data, whether it's from migration perspective, that NAS migration perspective, or even from archiving perspective, where we are moving the cold data to cloud, which is an object store, right? We do persist all permissions, all attributes, A time, M time size, we do MD5 sum, we do hard links, soft links, right? We're able to support all of them as we are able to, migrate the data, move the data as well. Right, so that's definitely very key for us and for our customers, because you really don't want to be able to lose any of those attributes as you move forward. Let me jump into, I think, great question. I really love the engagement. So please keep them coming as you see something else you want to ask during the demo as well. So I think second part of the demo I want to talk about is our deep analytics capability. I showed you, during our, assessment, during your assessment of the data, Komprise gives you this aggregated view, aggregated info about the data that you can see to make some decisions about it. But a lot of times, and our customers, what they want to do is they really want to see, hey, where do these files belong? They want to be able to customize the query. They want to find that needle in the haystack, because as you mentioned, Jason, we're talking about environments where there are billions of files, right? You find these, okay, great, you told me there are 240 terabytes of video files sitting. Where are they? How do I find them, right? How do you tell me in a way that I can really use the product and exactly go to those business users and really talk to them about what to do with it and have that intelligent conversation with them backed by the data, right? So really that's where our deep analytics comes in, where it really gives you and finds that needle in the haystack that you're looking for. So let's say, right, in this case, I want to find all my data. And one key piece over here is, this is not the data sitting on your one cluster, right? You may have 4 or 5 clusters within the data center. This is not the data sitting on one platform. You may have multiple storage platforms, and that's what we see when you see environments which are 10 petabyte plus and more. They don't have dealing with one storage vendor. They have multiple storage platforms in their environment, and most of them has been through acquisitions or different ways have accumulated different storage platforms. And it's not just one data center, it's across your data centers, right? So that's really the power of the deep analytics. It's your metadata index across all your unstructured data sitting in your environment. So here you can come in and
Mohit,
say, okay,
you were very careful to say it was a metadata index. So you're not cracking the data open, you're not indexing the files or any text or whatever is inside. It's just all metadata that we're working with.
It is all metadata. Here. That's absolutely right. Yeah. So in this case, I want to say, okay, I want to find all my video files, and see kind of, where that exists. So I quickly kind of run the query and I can see exactly there were 300 terabytes of data. Let me go ahead and save this query. And now you can exactly see where are these video files. You can click on the view files found. It will give you some sample files. You can exactly see where they are. You can exactly see who owns them, which shares they belong. And you can really drive this using an API, all REST APIs, to get the list of all the files you want. Really download the list of all the files you want. So you exactly have that information with you when you're having that conversation. And it's not only just for IT, it's also for your business users. And that's what customers are using, right? Even in the case of Pfizer, the research group in Pfizer comes in this console every day, and they're running the queries, finding the data based upon a project, based upon some metadata query they want to run, and find the data about that project, and then see how much of that data is old, and then tell the IT, okay, we go ahead and move this data to the cloud now. So we make it kind of very easy for customers to find that needle in the haystack. Now, once you found this needle in the haystack, you really want to take an action on it, right? That's the key part of. And that's really what we're doing. We're showing you a preview of what's coming very soon. It's not out yet, but that's our deep analytics action, where based upon these query results, it's very easily, you can go on the plan page. You can say, okay, I want to create my new plan here. If I can spell it properly in the live demo. And you go ahead and you say, okay, I want to import data from my video files archive query that I created. And all you do is, okay, and I want to move these files, and it automatically figures out how much data is going to get moved. This is exactly the 314 terabyte. You get that cost savings. You can move that to the cloud. It's really very powerful now, where you can really customize your policies based on exactly what you're moving. You can see what's going to happen using the deep analytics page, and you can come on the plan page, then use the deep analytics action and really take some action on it. And just to give you an example, we have a really big research institute who really wanted to have that bunch of these DAT files that they wanted to move. And they really couldn't figure out where they are, who owns it, how do I make a decision on it. And with the deep analytics, now they're able to do that. They're able to really move those files, archive it much more aggressively, because these DAT files are different than a lot of the other cold files. They want to move them with an aggressive 3-month policy as compared to the rest of the data that could be even 1-year policy as well. So that's really kind of what's coming out in the fall this year, and we wanted to kind of show, give you guys an early preview of our deep analytics action capability, which is really moving the data based upon a deep analytics query that you have built in your console. So with that, I think I'm going to do the one last part of the demo, which is, if there are no questions about that, which is really, once you move the data using TMT, what does the experience for the user looks like? Okay, how does he interact with it? What does he see? What does the application see? Is there any changes to the users and application at all? And the answer is it's very transparent for them. There is no agent at all. Let me see if I can show that to you. Yeah. So there is no agent installed. I'm showing you this kind of from a user perspective right now. That the user comes in, goes to his, let's say we move data from their NAS share, and it's an SMB share. They come in, they look at the data, and in this case, if you go back to my demo where we moved the video files, so if you see all the video files have this shortcut icon, which is really they are symbolic links that we have created. But they're very transparent to them. They click on it, it works. They click on the hot file, Komprise is not in the picture at all. It completely is very transparent to the end users, right? And this is all done through native file system constructs. Komprise is not doing anything proprietary here. We are not modifying it anyway. We have this, we have no agents installed on this laptop at all. And whether it's application or user, it's kind of very seamless for them completely. And I don't know if you can see it, it's a little small here, but these are like 7 files that have moved, which has those kind of symlink icons on it, because they're nothing but a traditional standard SMB symlinks that we have created here. Now, the other part of the question, I know Ray, you had a question. Hey, what happens in AWS? How does it look like here? Is it native? Can I use it over there? So if you kind of go back on my web page here, this is where the data has been moved in my bucket. And as you can see, all of these files are exactly the file names, the path of them, how they look, exactly the same. It's completely native. And most of the storage tiering products or anything else, what they do is they really, when they move it to the cloud, they're really doing it in blocks, right? Because they're kind of the storage product. We are managing at a file level, because what we really want to enable is where you want to be able to access this data natively in the cloud. And we have customers who are actually, and I think Pfizer is one of them, where their research group was very excited to see that, hey, I'm going to be moving my compute to the cloud tomorrow. This data is natively accessible over S3 protocol in the cloud tomorrow as I modernize my application, right? Rather than being locked down into your current storage environment, right? So we have you take control of your data rather than someone else taking control of your data. So that's really, I think my end of the demo. So kind of if I quickly summarize, we looked at, hey, how you can use Komprise to assess your data and really take some intelligent actions. A power of deep analytics where you can find that needle in the haystack and again, take some actions and smart actions on it. That's kind of coming new. And also, what does the TMT, how does it look like from the end user perspective, completely native for the users, for the applications, so they can access the data from the current environment, but not only that, for the future, they can access the data from the cloud as well.
I have a quick question here. It's about so how often the observer observes the data, and then can you set up policies to raise alarms if something changes too quickly, or there is something wrong with my data that happens all in a sudden?
Great question. So we are constantly scanning. You can set the configuration where how aggressive do you want it to be, right? So that's all configurable in the product. You can definitely configure it. And I think your second question, Enrique, great question. All I can say is that it's going to be coming soon. It's on our roadmap, where you can really, today you can generate those reports yourself and generate alarms, because you can collect all of this data yourself. And one thing to add to that and how customers are doing that, I forgot to mention, because we have created this technology, thinking about modern technology stack, API first methodology, anything that you see I showed in the UI can be driven through our REST APIs. Right? So what customers are doing today to that is they get that information using our REST APIs, so they can really track it. But what we will be able to do is give them that insights in advance where, hey, what kind of storage you're using today? What is your growth today? When will you hit the capacity, and alert them appropriately so they can take actions.
So Mohit, what about high availability? So I mean, this is migrating hundreds of terabytes, if not petabytes, of data off to the cloud, and you've got your virtual appliances there. Would it be considered a high availability solution?
Yeah, I think you know what? I think that may be a great topic for. I know Mike will be covering some high availability as well, but I'll just do very quick summary. It's really, as I mentioned, it's a scale out grid architecture, and those observers automatically handle the high availability. So if one goes down, there are others running, they take over. That's how we have architected the whole solution to begin with.